So I want to now, let me just tell you what I want to do. So I want to take, for a minute, I want to continue down the path of growth theory. And that's a good way to go, because for me, I want to get to the point where we have some empirical test of all of this. It's not going to be a very powerful test, but it will be some starting point. Why should we believe in the aggregate production function? That question we would have some chance of answering. So, okay, that's where we're going. Okay, so let me start by motivating where we're going to go. So I'm going to, as a result, there's a large empirical literature on this subject, which is called sometimes the literature on development accounting. How do you account for differences in development? That's what it's called. I want you to, the next step in what I want to do is to take you to that literature. Think about development accounting and what the literature shows and why, as I said, I think it's still a pretty weak test. So what are we going to do? We're going to look at how can we test the idea that an aggregate production function exists, or that it does a pretty good job of describing the world. Not perfect, of course, nothing's perfect, but does it a pretty good job of describing the world or not? Okay, so this is kind of boilerplate growth theory. You might have seen it. If you haven't seen it, it starts from this equation here, which is saying that, remember people had these utility functions which were, conventional concave utility functions. Then it must be the case that this Euler equation must hold. That's your optimal consumption path. Your optimal consumption path, what this says is that if this is the interest rate and this is your discount factor, then your marginal utility of consumption, 1 unit of consumption today, if you don't eat it, what do you get? Well, what do you get? You get R. R is the interest rate, so think of it as being, that's the extra bit I get. I lose the delta part of it, so delta times R is my, delta is the loss in weighting, and then that's going to give you, so $1 will effectively turn into delta R dollars tomorrow, and delta R dollars have a utility price. Utility price is U prime of tomorrow. So if this is not, this has to be true in equilibrium, because otherwise you should increase your savings or decrease your savings. So as long as you're free to choose your savings, and this will be true at the individual level, it will be true at the, under these assumptions of perfect markets, it will be true at the individual level, it will be true therefore for everybody. And then this last step is just saying that the production function is determines the interest rate. The marginal product of capital determines the interest rate. Okay. F prime k is equal to R. Okay. Now we have all the pieces of that. Okay. So if delta F prime k is bigger than 1, this ratio must be bigger than 1. This ratio is bigger than 1 means that your marginal utility is falling, which means your consumption is growing. That's essentially all of the proof of convergence. Everything else is minor details. And likewise the other way around. consumption must fall if delta f prime k is. So as you accumulate, as you save more, so consumption, this says that if delta f prime k is bigger than 1, your marginal utility will fall. That means you have to be richer tomorrow. Means your capital must go up tomorrow, because how will you pay for that consumption? You must be richer tomorrow. But if you're richer tomorrow, then your marginal utility will fall. That's where the convexity of the production function, production said, the fact that the production, this diminishing returns to capital will matter. And if there's diminishing returns to capital, at some point, you will get to a steady state where your capital is delta f prime k is equal to 1. Consumption doesn't change anymore. Convexity gives you that. Okay, this is completely boilerplate game theory. There's nothing, growth theory, there's nothing interesting about what I said. You should have, this should be familiar, the idea of convergence. So what this says in particular is, in this model, I'm going to, if I assume that the f is the same for all countries, it's important, and that's why I say the tests are going to be weak. If I assume in addition that the f's are the same for all countries, then what we will get is that the f is the same for all countries. So if a country has a lower c, it must have a lower k. Why are they eating less? Because they have less capital. That means their marginal product must be higher. There is diminishing marginal product. So if you have less capital, you must be poorer, richer. So your marginal product must be lower. Yes? So therefore, what must be the case is that your marginal product, your growth rate, this is roughly your growth rate. In fact, with CRRA preferences is exactly your growth rate. Your growth rate must be lower if you're richer. Because f prime k is lower, this number is lower, so this ratio is lower, this ratio is lower, this ratio is exactly your growth rate in a sense. Okay, so that means that poorer countries should grow faster. And one thing we know is that that's not true. When people ran their regression, it's not true. Very, very obviously not true. Poorer countries don't grow. On average, they don't grow faster. You see more dispersion in the growth rate. Poorer countries grow either faster or slower, but the average is not particularly related to. You can look at the plot in Mankiw-Romer and Weil 1992. You can look at the plot, and the plot is a nice cloud. You can. It really is like a cloud around zero. Really poor countries sometimes grow faster, some grow slower. Doesn't seem to be. There's more dispersion, but not more. Now, one thing they also show is that.
You just said that we observe more dispersion in growth rate for poor countries. Just a I don't know the paper by Mankiw-Romer, very much in the shame we should. Just do they exclude countries that face wars or?
No. Their point is, remember, their whole exercise is all of those are potentially endogenous outcomes. So let's not treat any of them. But even if you exclude countries, I suspect that I think people have done a million things on this. I won't guarantee that they're exactly the one you're saying, which is exclude wars. Because some wars are clearly results of endogenous outcomes. They are wars because the government has failed completely in delivering. That generates civil wars. So it's hard to know exactly how to do that, the exercise. But people have tried many things. I I don't want to spend too much time on it, but in fact people have tried many, there are many people. This is one of the most cited papers in history of economics. So it's like many people have written papers on this subject. Okay, what they do is they say, well, there's conditional convergence. That is to say, poor countries that grow, that invest the same rate, at the same rate, grow faster than richer countries. So you take a rich and a poor country who have the same savings rate and the same rate of investment in human capital. Then the poorer country grows faster. Is that what does this tell us? Does this, let me put it differently, is this the same claim as the claim of convergence?
Well, not really, because claim of convergence says that the markets are perfect and you don't really need any policy to achieve this result. And they argue, okay, countries that have the same policy and monetary policy.
That would be a different claim. This is just a difference in savings rate and human capital accumulation. So that would be a yet another claim, which is controlling for policy. There people have run that regression as well. But this is a different one. So these you could think of it as parameters of people's behavior. People are more patient in China than in in Benin, and so here's what you want to worry about. You want to worry about the underlying. What is the exercise? What they're trying to do is they're trying to say, I'm going to explain how much of the world can I explain by assuming that every country has the same production function, just different levels of capital and labor, right? That's the convergence question. Now, if you think that what's different among the countries is precisely the things that make savings happen, those could be they could exactly be their productivity. So the production function, the reason why some countries have high savings rates might very well be because savings are very productive in their country. That would mean they would have a different production function. So we don't know when we compare a poor country which has a high savings rate, is that because of preferences or because of difference in production function? And if it's difference in production function, then we start to worry that we are not explaining, playing the same game. We are no longer explaining the data by saying that, these countries, have less capital, therefore they behave indifferently. We are now saying something else. We are saying these countries are different, therefore they're behaving differently, which is a less interesting claim.
Yeah. Sorry, very basic question, but if you look at, for instance, many countries in sub-Saharan Africa, you see that people will spend as much as 80% of their revenue on food in normal years, not in famine years. So which means that if you must spend almost everything on food, you just can't save. Or if you save, you just destroy your human capital.
So now you are getting us into some place which it's interesting. There is a whole literature on poverty traps, and you're getting us close to that. But that in a sense is saying something about the convexity of the utility function. The utility function below a certain point, because in a sense, think about the problem of somebody who making the argument. If you're making the argument that people, when they face starvation, let's say, they don't save. Well, savings, remember, is about today versus tomorrow. So you're saying that they must be prepared to save tomorrow, to starve tomorrow. Because savings, after all, is all about the trade-off between today and tomorrow. So it's saying something about the shape of the utility functions. And you're exactly right. And there is a literature which maybe if I have time I'll talk about at the end on poverty traps. And one of the stories of the poverty trap is exactly the one you are saying, and there you need to make the right assumption about the utility function. It's not a trivial assumption, because you can see what the problem is. The problem is, if I take the class of CRRA utility functions, I'll never get that. Why? Because even though I am poorer, my trade-off between today and tomorrow is just like somebody else's. His level is higher, but my trade-off between today and tomorrow is exactly like that other person. Because I still, I'm saving because I want to have more tomorrow. Now, it's today I'm starving, but tomorrow also I'm going to be starving, so there's no particular reason why I wouldn't have the same choice as somebody else. So you have to move away from a kind of standard class of utility functions to get there. There are people who use the Stone-Geary preferences to do that, and this is a preference which basically doesn't have convexity, and then you do get those things. So it's not that I think you're completely. I mean, that's a completely reasonable thought. It's just you have to think about the fact that it's not just the fact that I don't have money today. Remember, by eating more today, I also don't have any money tomorrow. So the trade-off you have to, in the neoclassical model, we decide saving by trading off today versus tomorrow. If I have time, my plan is to come back to that, but we'll see how fast we go. Okay. So then the next thing Mankiw and Roman does, it says, look, these tests, they're all kind of, as we just discussed, they're not very powerful. I need to assume that the production function is the same to control for savings and human capital investment rate, but once I've assumed the answer, that's not that interesting. If I have to assume that these things are in the neoclassical theory, production functions matter for these investments. So how can I control for investment rates? Okay, so they have a different strategy. The strategy is, let's forget about growth. Let's look at levels. Let's just look at GDP, and let's see if we can explain GDP, not just account for GDP, by using these aggregate measures. In a sense, that's exactly what we started from. We started from the claim that we can explain all variations in GDP by using a production function, and in particular, they want to say, let's assume a production function which is identical in all countries, and see if we can explain all of GDP. So we're looking for a high R square, basically. We're trying to see if if I run a regression of GDP on human capital, labor, and physical capital, what's the R square? Is that clear what I mean by R square there? I'm trying to explain what part of the variation in GDP is explained by these factors. And I want that to be a high number. I want to say that I can explain 80% of GDP by using just these things and nothing else, no details about the country, other than their capital stock, their human capital stock, and their labor force. And if I'm going to explain nothing else, take nothing else, and if I can explain most of the variation, then in a sense the aggregate production function is a pretty good construct. So I think this is their most interesting part of the paper. So assume a product, and when you look at what they do, it's very important to keep in mind what they're trying to do. They're trying to say, I'm going to take and completely, I'm going to load myself to fail. I'm going to make sure, I'm going to make very strong assumptions, and why would I make very strong assumptions? Because my whole goal is to see if even after making very strong assumptions, I still succeed. The power of the test comes precisely from setting up to fail. You want to say, I made these very minimal, I didn't allow the production function to be sophisticated in any way. I took the most standard, most boring production function, and I could explain 90% of the variation. That would be success. If I had to take a production function that looks incredibly complicated, that would be less credible, because people will say, well, why did you pick that production function? So they're picking a production function that's extremely simple. This one. And this is sort of the production function that US data supports. It's not quite, but they have some argument. You should read the paper to see exactly what. But it's a production function that looks pretty close to what US data supports. They modify it slightly, but mostly they're tying their hands. They're making it very difficult to fit the data. Do you see why am I emphasizing that? Because you might say, why that production function? Their point is, no, that's the opposite. I am making it very difficult for me by assuming that production function. I didn't assume, I could have had a CES production function with many different elasticities of substitution between the factors. I'm doing nothing of the sort. I'm assuming that the elasticity of substitution between the factors is 1. That's a Cobb-Douglas. So that's like extremely restrictive class of production functions. So then they rewrite the production function. This is trivial. What they do is just divide by y to the power of alpha, and then they get this. So why are they doing this? Well, they want to use the savings rate. Something like this is the capital output ratio, this is the human capital to output ratio, these numbers is what they think they have data for. Okay? So I say the word they think advisedly, but they believe they have data for these things. Okay? So that's that. So what they're going to do is they're going to fix A, completely ignore A, assume every country has the same A, and so run a regression of y over L on k over y and h over y, and effectively look at how much that explains. Not quite. I'll say what they exactly do in a minute. Okay. So how do they compute? So this is all sort of, they're making very brave assumptions. The whole point of their exercise is, look, I'll do some complete, I'll do something completely, cheap to do, but also completely unjustifiable in a sense. And remember, my whole goal is to fail. If I don't fail, that's remarkable. So I'm going to make assumptions that seem very hard to justify and see what we get. What is the assumption? They assume that, essentially every country has, so what they do is they take the savings rate in each country, which already is a extremely badly measured number. I mean, for many countries in the world, the savings rate is mostly made up by the World Bank, but take the number that the World Bank makes up, in any given year. It's probably mostly made up. And then divided by, make the assumption that each country has reached the steady state. That's a ridiculous assumption, right? That every country has already arrived at the steady state. When you have arrived at the steady state, your capital stock must have a relation to your savings rate, which is given by that. Why? Because your capital stock. So let's rewrite that equation just to see what it is. we write it as k over y times delta plus n plus g equals ik over y. Okay, I rewrote. I just move. If you can't see, all I've done is I've taken this and I multiplied it there. Okay. I didn't cheat. Okay. So what this is in steady state. The amount of capital you have, how much do you lose of the capital every year? Well, delta is the depreciation rate. So you lose some for depreciation. You lose some because basically your labor force grows. And if your labor force grows, your capital per worker goes down. So I should allow for that. And maybe your productivity grows. And therefore, again, your effective capital per effective worker. Because your workers are more productive, the capital per effective worker goes down. So I should control for these three things. And then basically, this is the loss in capital in a given year. This is the amount of extra capital I'm investing. And those should exactly be equal. That's what a steady state means. It means the total capital that kind of leaks out because of depreciation, because the population grows, because productivity grows, is compensated by how much I invest. So that's what they use. And remember, these numbers are, the depreciation rate they pick is 3%. Why? Because maybe that's what it is in the US or some country. The productivity growth rate for per worker is 0.2%, and again they assume it. And the population growth rate, I think they allow it to vary by country. It's the only thing they allow vary by country because that's the only thing they know. They don't really know anything else, so they assume that the other numbers are the same. This then allows them to compute that and compute that. Okay. It's an extraordinarily brave exercise. You can see what they're doing. They're like making assumptions right and left, and coming up with numbers. Then the last thing they have to do is they have to decide how to measure success. How do you measure success? Well, you take, you can see that basically, let's go back here. This is the x here is just this product. This product is x. Define it to be x. A times everything else is x. Take logs, you get that. And then you take the variance of the log. So you're trying to explain the variance of the log. You remember, we're trying to explain the variance of GDP. So we're taking the variance. This is the variance. This is the variance of log A. This is the variance of log x. And this is the covariance between the two. This is just the variance formula. Okay? And the question is, what do you do with the covariance term? In the sense that you will part of this covariance. So why is the covariance term an issue? In this exercise, why would I worry about the covariance term? Remember what they're trying to do. They're trying to explain everything by just the variation in inputs. What's the omitted variable concern here? The omitted variable concern is, I can be very patient.
TFP.
TFP, exactly. What's the omitted variable concern is that the x is picking up the a. You're trying to get rid of the a, right? You just say that I'm going to explain everything with no variation in a. But if x reflects a, what do you do about it? So what they do is they kind of go halfway. They use this, the correlation covariance between YL and log x, y over L and log x, and that's if you do the computation, then you'll see that that takes half of this variance and assigns it to this. This is just, one line of calculation. Convince yourself that they did it right. All they're doing is they're saying, well, what do I do? Well, I'll just assign half of it. I'm going to, and the nice thing about that is that to get half of it, I just use this formula. The covariance between y over L and x picks up exactly half of that variance. That variance could be everything, could be nothing. They have no idea, so they just assign half of it. Just very brave. Now, here's what's fabulous about what they find. After all these assumptions, they say that, look, I made up this number and then I did any kind of stuff. Now, this is the one assumption that you might complain about, is this one, because this is maybe making it too easy for them. They're saying that the productivity, they're just going to, if all of x is determined by a, then in a sense their success is not as great as they would have wanted, because they're really picking up a. But everything else is kind of, as you saw, were completely, they pull to use an elegant American expression, they pull the assumptions out of their ass. So now you take that, and what you see is that they can explain 78% of this number is 0.78. That's a remarkable result. I made any kind of assumptions. I assumed everything was the same. I threw away any data that was country specific except the population growth rate, and I get that. It's kind of a remarkable result. Country specific, only things I use are this I over k, or ik over y, and ih over y. Those I get from the World Bank, which mostly made it up. Now, one worry, of course, is the World Bank also made up the GDP. So maybe those are correlated because everything was made up. But they do it on the Penn World Trade Tables, which does an honest job of calculating GDP. So maybe that's not a problem. But if you leave that out, this is a remarkable result. Okay? 78%. This is now at the yearly level. Every year, I take the GDP. I regress it on basically these two variables and see how much it explains. It's a fantastic fact. Now, turns out it's not entirely true, but it's sort of, you can see why people have written many papers about this. It's sort of a fact that you must be impressed by. If you're not impressed by it, then I've not explained it right. You should be very impressed by this fact that I just make any number of assumptions. I assume everything's the same. I allow no forms of local variation, and I can explain 78% of GDP. Okay. I assume steady state in every country. It's a kind of breathtaking assumption. It's hard to imagine. China is in steady state. So is in India. So is the Democratic Republic of Congo. I mean, it just doesn't seem plausible. Okay. Now, unfortunately, as you might imagine, there were other people who didn't like this result. So they did a bunch of stuff. You can read the stuff that I say, but mostly the key thing that seems to matter is how you measure human capital investment. So you can measure human capital investment. So what they had done is they had used secondary it turns out that they had used the time, they had picked the particular measure of human capital that gave you a lot of power. So if you use secondary school enrollment as your measure of human capital, you do very well. That's Mankey, Romer, and Weil. But why use secondary school enrollment? After all, most countries have a lot more people in primary school than secondary school, especially in 1960. Very few countries have secondary school enrollment. And you worry that secondary school enrollment is picking up all the things that A is picking up. So instead, they take some weighted average of primary, secondary, and tertiary, weighted by the Minserian returns, the returns to extra years of education in the country. So take the Minserian returns in the country, weight it by the years of education by it, stick it in. And then the fraction that you can explain goes down from about 80 to about 40. So everything turns on the measure of education, it turns out. Okay? So that's one worry. In addition, if you also worry that education is mostly produced by other people who have human capital, that machines are less important in education, especially in 1960 when they were very unimportant in education, then you allow for that, then it goes down to 33%. So that's a less exciting number. Still impressive in a sense, but still less exciting. Now, I'm going to, something happened. Okay, it doesn't want me to say anything more, but I will. So, of course, that didn't end the debate. Nothing ever ends the debate, but this started a new debate. And so people went back to fix those measures again. So one way to go would be to use the quality of education. So Pisa scores. So take countries which have differential Pisa scores. Pisa is a test that is done by, I don't remember the name of the organization, OECD. OECD does the test. It's a cross-country test. Unfortunately, very few developing countries are represented in it. Now, if you use Pisa scores as a measure of the productivity of education, because after all, years of education is not human capital. Years of education is just years of education. Then you have to decide. So another way we would have gone is just take the Pisa scores. Now, the problem with Pisa scores is they are extremely selective, the number of countries that participate. Within the countries, there's huge selection. China only allows Shanghai and Beijing to participate in Pisa. So, the Chinese Pisa scores look very high, but Xinjiang doesn't figure in the Chinese Pisa scores. India, for 1 year, allowed the state of Tamil Nadu, which thought it was very good at education, to participate. It did so miserably that since then India has refused to participate in PISA. I think this time it's participating. But these are, so the PISA is very selective, the participants are very selective, the country selection is very selective. Most countries don't join PISA at all. So you have a very strange sample of countries, very strange sample of data. So you could, that's one problem with running this regression. What's another problem? So one thing you could do is put in PISA scores instead of years of education. Why would you not want to do that? TFP. Again, the TFP of the education sector is what you're measuring. If the TFP of the education sector is correlated with the TFP of everything else, you're picking up just TFP. Sorry?
Or close command, reverse causality, but
that too, possibly. But certainly you may. Okay.
Okay. Difference between TFP and reverse causality. Reverse causality may be an issue also for the number of years of education. Now you got to assume
yes, absolutely. So in general, you worry that, but that's exactly the point we were making when we said that there was a correlation with A and X. That's your point of reverse causality. But I think here you're really taking on TFP, because after all, this is the marginal effect of the education system conditioning on the years of education. That's almost purely TFP. So if you put TFP on the right hand side and you show that TFP, there is no other TFP, that's not that surprising. So that's a big worry. But there's another class of papers which makes the following, I think, interesting observation. I'll make that observation and stop. Well, they observe that, how do we construct the total number of, total investment in education? Well, as I said, I take the number of people who have primary education, I multiply by the return to primary education plus the number of secondary education times the return to secondary education, etc. When I do that, I'm assuming they are perfect substitutes. That is to say, maybe 2 people with primary education are as good as 1 person with secondary education, but they're perfect substitutes. Now, if I wanted to, what makes a big difference is if you assume that they are complements. So why does it make? Think of what PSE does. PSE takes a bunch of extremely talented people and puts them together in one place. They don't pick people at random, and the reason why they don't take people at random is because they think that human capital are complements, not substitutes. And that PSE exists precisely because you believe that they're complements. Now, if human capital are complements, then the difference in human capital across countries can be much bigger than what we think it is. We add up people, but we can't add them. We should take the top people and say that if I have 100 people who are really talented, the total production of the total amount of human capital is the product of their human capitals or something. If I believe that, then France could have a lot more human capital than Benin. On paper, it looks like France has maybe 3 times as much human capital, but if I assume the production function has complements and I make the complementary strong enough, I could say France has 100 times as much human capital as Benin, because it has many more PhDs, and if PhDs are complements and I take the total number of PhDs and I take the power of that, then I'm going to get a much bigger difference between France and Benin, because these people, the idea would be that these people work together and therefore they increase each other's productivity. Now, that could explain all of the data. There's a nice paper by Ben Jones, I think in the JPE. Ben Jones was one of my students many years ago in the JPE, arguing exactly that. Now, the problem with that view, and I'm going to say that and stop, is okay, it's not working, fine, I'll just say it. The problem with that claim is that if you believe that, which is to say that there's huge complementarity, then rich countries where it's easy to match with high human capital people, the returns to human capital of tertiary education should be highest in rich countries. Because in rich countries, I can go to PSE and work with other PhDs, whereas in most countries I can't. So the return to my personal human capital should be high, but it's not. If you look at the Minserian returns, they're not higher in rich countries. If anything, they're lower. PhDs are more valuable, earn more valuable, I don't know, earn more in poorer countries. So it doesn't look, it's not obvious at least that this is what's going on. But this is an interesting thought. So to summarize, basically once you open up the production function of human capital, there's just so many degrees of freedom. You can certainly generate a number that will fit the data. You can go back to the 80% number if you just pick the production function. The question is, do we believe the production function? So it again goes back to the question of, we start to look at Minserian returns. We start to go back to the microdata to see if we believe the model. So in the end, I'm going to make the case that this is not a question we can resolve on the basis of this exercise, because in a sense all these tests are, assume a lot about the production functions. To do any of these tests, I'm assuming a certain production function. If I allow me to construct a production function, I might be able to fit the data much better. There's just too many degrees of freedom there. So I'm going to next time make the argument that we should rather look directly at the data. Do the assumptions of the aggregate production function, are they satisfied? That's a better way to look at this question than to try to resolve it using macro data.